Hi, I'm with another teacher here, the head of science in our school, Jennifer English. And as I said in the previous videos that we were doing, or part of the same segment, teacher would bring me a question, and we would look at that question and see how a matrix was developed around that. Jennifer is taking a different approach in that we're going to look at how alarm can be used to bring about a whole faculty together and make it more of a learning community within the faculty. And we're going to go through this systematically and look at each one. The first case that she has is an alarm matrix with sort of a generic one working with science in general. So if we'd like to go through this, just look at each point and see how it is. So it's not a question as yet, it's just trying to see a generic type of matrix. So how have you formed this? You began with the name and you put in the hypothesis and aim.
Yes. When looking at working scientifically and developing a report writing process for working scientifically, or even designing a scientific investigation, first-hand investigation, the place that we start is why are we doing it? The name of this experiment, the sentence that defines what this experiment
has to begin
there. So,
okay, so I'm assuming even the working scientifically, that's the entirety of science, so to speak.
Essentially.
Okay. So then you have to go, of course, from there, then you go into the procedure next, and you would have to describe the procedures throughout.
Yes. So the description of the experiment is what you do. So essentially, it's the method or the procedure of the process you go through when you carry out the
That's the details like that. Okay. Just a little bit back. So this is good for practically any year.
Yes,
is it good
it would apply from K to 12.
Right across the board.
Yes.
Okay. And then explains to you is conduct and record data results. Yes, that's sort of the impact of what they're telling you in there.
Yes.
And then analyze, process data. That's where I'm saying is sort of the how. You have to know how this data is showing me something where you're tabulating.
Yes, and so this is where you would start the explain the significance is what happened when you carried out this procedure, and then the analyze is that first step of okay, now I've got this data, what do I do with this data to then be able to critically analyze what happened?
Okay, so I always draw a line here in that this is my content,
yes,
and that's what I'm going to be doing with it.
Yes. So I see these skills of tabulating and graphing, the basic skills of tabulating and graphing, of still being the content of science.
Yes.
It's the analysis of that then becomes concept.
Yes, finally when we can get to concept down here.
Yes.
Okay, so it just follows the generic tablet or table that or template that we've been using even in our first series where I've been trying to do presentations. We're still following it, that these are the positives and negatives, so to speak, about the analytical data, is trying to show these trends and patterns to finally come to this, to what extent.
And
there's your scientific terms there too. Reliability. So this is a meta language too.
Yes, but in terms of scientific method, I saw the evaluate as not just being about the data, but being about the whole process. So,
okay.
Is your data reliable? Was your procedure a valid way of carrying out the experiment? Did the data you get, was it accurate? Is it reliable data? How do you know that? So that is
that's
more
kind of
your
levels.
Yeah, that's more your evaluate in a scientific method sort of way.
Okay, and then you finally come back sort of to your hypotheses here.
Yes.
So your conclusion based on evidence and hypotheses. So that's your conclusion here.
So in scientific method, or when you teach students to write a working scientific report, the conclusion is only based on the hypothesis. So that's where you're essentially saying whether your data proved or disproved your hypothesis.
Okay.
So based on all of this, the reliability, the accuracy, the validity, can you say that your hypothesis was proven or disproven?
Okay.
So it's a nice little circle.
It's still the learning side, and then how it just will flick around. You can actually, would you think that is sort of the answer then to
Yes.
the scientific method you've been using? And then you get to the topic here, how does this relate to what you know about the scientific concept?
So the next step in a scientific first-hand investigation is, okay, you as a student found this out, but how does this relate to what your teacher has taught you about the concept? And then further, how does it relate to what scientific evidence already says about? So not just your teacher, but the scientific community and experimental method that they've applied. How does it apply to real scientific research?
So in aligning these skills, basically, I mean, you'll fill in the boxes with the information, but through these skills, it's really helping a relationship happen right across every year and every topic, perhaps.
So, yeah, and for every first-hand investigation. And you can do this at any level. You don't have to use necessarily those words. You'd use the meta-language that's appropriate to the year group, which is, so for prior to year 7, you're talking about changing something, keeping something the same, measuring something, whereas as they go up, it's about independent, dependent variables that come in the procedure, or in the reliability, accuracy and validity of an experiment.
Okay. I think a good way to go now is, how can I use this to know to what extent, how deep am I supposed to go with each topic? You know, so I want to know how can I use alarm to know when do I know this cutoff point? I mean, each one, but the content and when you go further with that content. So I suppose another way, but actually you've covered that as well in your next template. So we'll move on to the next template. Here we have a science program, content overview, and the topic is forces. And I noticed that what you're doing is you're actually looking at the syllabus outcomes under the name.
Yeah, I wasn't sure whether to put them outside of the name, but as they were actually naming what the syllabus outcome is, it's the outcome that we're trying to get to. And I often have difficulty separating name and describe. Often, and in some of the alarm training that I've done with you,
yes.
This is name and define, and often a definition in science is very close to a description in science.
Okay. Yeah, so, I'm not going to change that at all because it is still part of the content, and we're still talking about what.
Yes.
At this stage, so that's fine, and I do want this to become part of someone's own practice as so forth. If we look at each one of these questions, I'll call these a question, or at least they're a directional, because in English, when you put the verb in front, of course, it's imperative. You're telling them to do something, which requires a skill. So each one of these, I suppose, would then follow levels themselves and levels here. But I have to first know what type of question is it asking. So if I look at this question, identify changes that take place when particular forces are acting, I'm basically dealing with the content. Yeah? So I need to know, okay, if I'm dealing with the content, how deep do I go? And what are the skills necessary to be able to accomplish that outcome? Okay, so let's go through this. So identify. So the first thing you're looking at is, what is a force? What do forces do? What are the units of force? Okay, so that's going to begin. And this, by the way, we should have mentioned, this is for year 7.
Year 7, yes.
Okay. What I'd like to point out, even though this is year 7, is this is a skill they still have to write through the board every subject.
Yes, definitely.
Has to be able to do that. Okay, so what is the force? So you're going through here, what force? Would they have some, if there was an actual lesson, they would have to then tell what the force is? Well,
that would be the objective. The way I saw this is questions for teachers as to what do I have to include, what do I have to answer in a lesson, what do my students have to know or have to be able to answer on a generalised level to be able to do this, what do they need to describe? But I thought framing it as a question was provoked thought rather than telling teachers
yes.
what content should be in there. I think asking a question makes it more open.
When I go through and I have developed matrices for myself, I first began with just the text. This is for English. Then I went to the question. Then I went to the module and to the unit. What you're doing here is you're going to the syllabus.
Essentially, yes.
Essentially, you are using the matrix as a means So I'm trying to clarify this. If I'm training someone, I need to know first, what level are you trying to do this, accomplish, or use a matrix for? So this is a matrix for the syllabus.
It is, yes. It's the idea of it was, how could I apply alarm to programming? I had such wonderful success in assessment tasks when I asked a question that then my next logical step was, if this breakdown helps students learn the material and then respond to the material
For a question, yeah.
then it could also logically be applied to how do I teach it. So these outcomes from a syllabus are effectively how do I, are what needs to be taught. And as syllabus. A teacher, from a syllabus point of view, and as a teacher you're saying, well, how do I do that?
Yes. And
what do I need to put in it to be able to teach that? So I saw the alarm matrix as a way of breaking these content or outcome statements down into their component parts. So I could be sure that I did explicitly teach all of those things. So for a student to be able to answer a question, they need to break that content down. But if they haven't been explicitly taught those pieces of the content, then how can they do it themselves? So this was, for me, a logical extension of the alarm for stage 6 is, okay, well, how do I break this content down for my students so they can make that progression themselves through it? If I don't teach it that way, then how can I expect them to create that for themselves?
I think it would be beautiful if kids were learning this in year 7, getting them coming to us with the skills ready for the stage 6.
And that's why I chose a year 7, year 7 program to start with.
So then, then we go back and to explain significant effect on content. What impact do forces have on objects? How do you measure the forces? Yes. And then finally, how can you measure, and I like the how here, the impact of forces on objects. And look, what I'm doing now is I don't need to use alarm beyond this point necessarily.
Because the outcome isn't...
The outcome isn't geared for that.
Yes.
Because so many times, if I've delivered a presentation, I get the question, do I use alarm the whole way? And that shows you don't have to, because the syllabus isn't asking for that.
And this syllabus, set of syllabus dot points actually works really well, because if you look down the progression in the syllabus dot point is actually building to a more evaluative process.
Deeper level process.
So it starts at a lower level type of outcome and actually moves to a higher level outcome. So even though each content dot point doesn't necessarily go to evaluate or even the critically evaluate or conceptualize, as you move through the syllabus and through the outcomes, it actually does build up to sort of what I call this corner of that.
Yes, that bottom right-hand corner. I try to get them to that bottom right corner all the time. So look at this. Predict the effect of unbalanced forces in everyday situations. So we're just going through again to this, how do unbalanced forces affect everyday objects? So I'm really answering that through that skill up to the level of content.
And what I thought about when I wrote these down is also, if I was doing a blank matrix for students, what questions would I ask them to prompt them to put into each of the cells in the matrix?
And it doesn't matter what year, or is this?
No, it doesn't matter what year.
I'm going to ask a question about how you did you work this with year 7?
I haven't yet.
Okay.
That's next year.
That's next year. Describe some examples of technological developments that have contributed to finding solutions to reduce the impact of forces in everyday life, example, car safety equipment, footwear design. I think there's even a year 12 question of physics on something like this. But look at this, have contributed. This is going to help the students, even in year 7. I would like them to know it in year 11 and 12, to know that as soon as you see this, you have to go out beyond that, just the content of like what are the stages of technological development that have impacted on force reduction, what are the advantages and disadvantages.
And even though it starts with describe, and I think in terms of teachers teaching this, they get stuck on the idea of describe, and in New South Wales we've been hammered so heavily with the syllabus verbs and what their definition is.
Yes.
That you see the word describe and you automatically think that it's low level, but when you get more into the outcome statement, it's actually much deeper than that, and it's not just about describing something, which would be here. This is actually all the way to evaluating the effectiveness of something or the impact of something.
So going back to my point about what type of question it is, this was a content type question. This was a type, of content type question too. This is content, but it's asking you to do something with the content and then make a judgment.
Yes.
Make beyond that. See, so once you know the type of question it is, even in an outcome, if we don't call that a question, at least it's a direction of what they have to do, it still holds true. What type is it, and how deep do I have to go? So then analyze, now do I stop at analyze? Some everyday common situations where friction operates to oppose motion and produce heat. So this one you want to go out to evaluate.
Yes.
Okay.
You probably wouldn't have to, but knowing, this is what I call hidden content.
Yes, that's good.
Because friction is used, sometimes we want to reduce friction. So in a car engine, you add oil to it to reduce friction because you don't want the parts fusing together. But on your bicycle, you want to increase friction between your brake and your tyre because you want it to stop you. So even though this talks about friction opposing motion, and then also there are a whole level of things of friction does produce heat.
Yes.
So even though you do want your tyre to stop, you need to accommodate for the heat.
Because you're talking about common everyday, you actually are linking to life.
Yes.
I got it. I think I learned something. It's because I have to go to the appreciate, which is how well is it managed in these common situations. You do have to know about life and why. Then you can even go beyond that to, yes.
It's the application of
It's
what
the
you know
application of
about
life.
friction and
Because so many
force.
kids in year 7, and I think in year 12 is why should I learn something, which is appreciate. And so that common every situation, that's dealing with life.
And it's not till you sort of have gone through this whole thing. And so the appreciate is how do forces and friction impact on your everyday life? And if you're going to get them to here, even though this says analyze, which takes it to there, you can't actually get to this level of appreciation without actually taking these next 2 steps.
That's right. One of the things I wanted to point out, and this is apart from this a little bit, is this word of being a hierarchy. Sometimes we think each of these skills, it's a hierarchy of this skill is more important than that skill. And our band 6s are more important. But what I'm trying to get across is that every lower or every higher order skill comes about because they had to have learned the lower order skills it took to get there along the way. So we're seeing this as a continuum of learning. And then investigate factors that influence the size and effect of frictional forces. So influence, you come to which factors influence size and effect forces the most. Yeah, and we have to go through the positive, negative here, which is more or less, and then finally I do it here.
So I think if you're ranking something, or even if you're looking at size and effect and looking at how things affected the most, even if it's just a critically analyse, I still think you have to take students to the evaluation. What's the point of listing positives and negatives if you then don't make a value judgment on that?
That's right. That's the therefore. Yeah, and then you're bringing all these together to how well did your investigation measure the factors that influence frictional forces? Why is it important? And we come down to this very high order here. Let me ask you a question. How does this help? I mean, I can see this it helps me delineate when I have to go further and and how I can get there, as well as when I don't. So how does this overall pattern help shape, like making a program or on a unit or a topic?
I've always had those moments where I think as a teacher, why don't my students get this? I taught them this. I know I taught them this. Why are they not getting this? And I get the assessment task and everyone doesn't get it.
Yes.
Why? What about this haven't I been doing? And it's not till I actually
So you're questioning yourself about why you didn't.
Yes.
Yeah, okay.
How is my teaching practice impacting on my students in such a way that every child in my class did not get this concept? What this has really made me realise is that I need to break this down. And perhaps the reason the whole class didn't get this, or most of the class didn't get this, is because I missed a bit.
Ah.
So I was trying to make, because
It's kind
my
of the
brain...
metacognitive approach for a teacher.
Yes, because my brain naturally jumped from here to here, not that necessarily, but because I'm now at an expert stage where my thinking jumps from a description directly to an analysis perhaps, or even a critical analysis or an evaluation, I automatically make that jump and don't appreciate that those people, there are students in my class who can't make those cognitive leaps by themselves.
Yes.
So by breaking it down into its component parts, I can now say, well, how am I going to make sure that I explicitly teach all of these things?
So this helps you control your teaching practice.
Yes. And then in terms of differentiation, it can be a matter of, well, for some students I stop here, or it may just be, how can I simplify this in such a way that they still get here, but not necessarily at a as high a level. So it also helps me to differentiate for certain students in my class as well.
Yes, differentiating the curriculum in delivery.
Yes.
Yeah,
So
rather
they all
than
end up-
separating kids,
yeah.
I'm only going to teach and differentiating the curriculum. This is a whole different topic. But in differentiating the curriculum, sometimes we think, oh, I have to just teach the kids these and to those kids. But then they stay there.
Yes.
But this way you can show everyone, not that everyone's going to get there, but at least I can differentiate it in my delivery and in my programming of the lessons.
Yes. And given the students I have in my class, how am I going to take them on the journey from here to there?
To here.
So they actually get that level of evaluation.
So will this help you inform, it looks like it will help you inform your total programming.
I hope so.